you still have different options for the calculations. And the simplest one is the shortcut with the calculation mode design. That means the default one, so you don't need to do any adjustment. Okay, but you will need to specify the heat exchanger specifications here. Okay, so there are many options here you can choose. For example, you can choose the hot stream outlet temperature or hot stream outlet temperature decrease, blah, 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 blah. And then the last two option is the heat exchanger duty. So you can put the value that we saw. Yes, what's that? That's about 180.05, okay? 180.05 kilowatt. Please be sure you have the correct unit, otherwise the result will be very weird, okay? And then, okay, I think all the rate sign has been cleared. Okay, let's see what's the simulation result. Okay. Okay. It give you a message like the value of parameters NRTL already exists for the component ethylene, glycol, and Freon 12 on the parameter form. So you can choose to replace it and with the estimate value of the PCES. Okay, so here is basically what we say. When you develop the thermodynamic model, especially for the NRTL model, you need to specify the binary inversion parameters for the pair Freon and ethylene glycol. Okay. So when you develop your thermal model, I suggest you to click estimating the missing parameters by unit factor. Okay. But indeed, Aspen Plus has the default parameters for this pair already. So that means that's why it shows you the it pop up this message like they have already exist the component EG and Freon 12 for the parameters. So you can they ask you to switch back. That means stay with the default parameters. You don't need to use the estimation of the parameters. Okay, so after you check the message and we can see the results like, okay, let's go to the E2, that's the heat X, and you go to the thermal results. And if you switch all the unit to the Kelvin and pressure, and you found something Okay, if you go to here, the result of B2, okay, that's the thermal result, and you see this panel. Okay, for the heat duty, that's exactly the value that you assign, 180.05, okay? But for the inlet of for the inlet and outlet of Freon 12, that's also identical. And for the inlet of ethylene glycol, that's the same. But the problem will be like the outlet, okay? Specifically, the outlet temperatures is about 320.4 K. What's new? 320, okay. So 320 is in a way of higher, I mean that's higher than what we designed. So that means a value, I mean the flow rate of 5,000 kilogram per hour for the flow rate of ethylene glycol is not enough. You have to have more, I mean you have to supply more ethylene glycol to lower the outlet temperature. So we can try the flow rate to a higher one, maybe 5,500 kilogram per hour, etc. Okay, that's leave that to that will be your work. But I want to show you is here. That's the summary of the heat X result. But here, the other one shown here, that's the exchanger detail. So again, the duty is 180.5 kilowatt. That's the one we assign. And it estimates the required heat exchanger area for you. Again, the heat exchanger area, it asks for an estimate for you is here. So that is, it requires 3 meters squared, okay? And for the average, for the overall heat transfer coefficient, okay, that's about 730, okay? For the heat X, you are not able to adjust the value of the overall heat transfer coefficient here. Okay, that's a default one. But you have to know if these values is valid in your case. How can you check? You can go to the website. Okay, anyway, you can link to the website to see to your fluid, to your system, what's the range of the overall heat transfer coefficients applied in the literatures, okay? That gives you more confidence about the problem.